Hello everyone, myself Sai Prasad, a lecturer in Allahabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths E. We started a discussion with our chapter Binomial Theorem. What did we learn? We started with the introduction of expansions, then we found out the coefficients, number of terms and all those. Fine. In the recent sessions, we did problems of coefficients for few sessions, then we did the expansion just before that, how to deal with those expansion, all those. From now we will do all expansion kind of problems. Okay, look at the first question today. It is given as if n is a positive integer and x is any non-zero real number, then he is asking us to prove that c0 plus c1 into x by 2 plus c2 into x square by 3 plus c3 into x square by 4 and so on up to Cn x bar n by n plus 1 is equal to this, right? It is actually a simple problem, but you have to use the brain how to use it. Okay, just see here, let us assume S is equal to this whole thing, nc0, nc1 x by 2, nc2 x square by 3 and so on up to ncn x power n by n plus 1. Is it right? This is S. Clear? Now, whatever you have on the right side term, just check all the terms. We have 1 plus x whole power n plus 1. We have minus 1, n plus 1 into x. If we correctly manipulate and multiply, we will get this term. Right? So, what are left? N plus 1 into x. So, let us, since it is in the denominator, that is dividing, now let us multiply x on both sides. Let us check what happens. Multiply x on both sides. So what happens? X into s is equal to nc0 into x, nc1 x square by 2, nc2 x cube by 3 and so on up to ncn x power n plus 1 by n plus 1. Right? Next, what is there? N plus 1. So let us multiply n plus 1 to all the terms now. Why? Since it is dividing on the right hand side, let us multiply here. Multiply n plus 1 on both sides. This will be n plus 1 into x into s is equal to n, let me write it as n plus 1 into nc0 into x plus n plus 1 into nc1 x square by 2 and here n plus 1 nc2 x cube by 3 and so on up to n plus 1 ncn x power n plus 1 by n plus 1. Is it right? Now see here, if you observe here, n plus 1 into nc0, what does it become? N plus 1 into n. Why, it is nothing but n plus 1 factorial. Yes or no? And here also n plus 1 into n divided by everything. Again this will be like n plus 1 c1. This is n plus 1 c2. That will be n plus 1 cn. Right? This will be like, what it will be? N plus 1 c0. So, can I write it as n plus 1 by 1 and here let me write by 2 here and let me write by 3 here and here also by n plus 1. So, what happens? This will be n plus 1 into nc0 is nothing but m by n plus 1 minus n, which is 1 factorial. Here also if you observe, n plus 1 into n factorial by n minus 1 into 1 factorial. Right? So if you observe, this will be like n plus 1 c1 into x plus n plus 2, n plus 1 c2 x square n plus 1 into c3 x cube and so on up to n plus 1 cn plus 1 x power n plus 1. Right? What is this term? nc1 x, nc2 x, nc3 x cube and so on up to ncn x power n. That is nothing but 1 plus x whole power n plus 1. This is n plus 1 into x into s, right? Or shall we missing something? We are missing the first term, that is n plus 1 c0. So let me add n plus 1 c0 x power 0 and subtract n plus 1 c0 x power 0. Till here it is 1 plus x whole power n plus 1. What is left? N plus 1 c0, that is nothing but minus 1. So from this I can write s is equal to 1 plus x whole power n plus 1 minus 1 by n plus 1 into x. Clear? Is it simple or not? But the thing is, just don't try to mug up, just try to understand. If you understand n plus 1 into nc0, that will be like n plus 1 c1, right? How do you get? Just try to understand. What is n plus 1 c1? N plus 1 c1 is n plus 1 factorial by n plus 1 minus 1 factorial into 1 factorial. That is n plus 1 into n factorial by here n factorial into 1. Both will get cancelled. I will be left with n plus 1, right? However, nc0 is 1. Right, here also if you observe n plus 1 by 2 factorial into nc1. Let me write like this: n plus 1 by 2 into n factorial by n minus 1 factorial into 1 factorial. So, how to simplify that? Can I write it as here n into n minus 1 factorial, right? What is it? N plus 1 n into n minus 1 factorial by n minus 1 factorial. This whole thing is nothing but n plus 1 c 2 into 1 factorial, that is n plus 1 c2. Right, try to understand in that way so that we can simplify and write it as 1 plus x whole power n plus 1 and minus 1. So this is my s, which is nothing but the given question. Clear? Is it simple to understand? Fine. Shall we go to the next problem, which is of same kind. Instead of x, we will have some particular constant. Shall we do? Let's do now. Look at the next question here. He gave, if n is a positive integer, then prove that c0 plus c1 by 2 plus c2 by 3 and so on up to cn by n plus 1 is equal to 2 power n plus 1 minus 1 by n plus 1. So how do we do that? It is almost similar to the previous problem, isn't it? So let us take same story. Let s is equal to nc0 plus nc1 into 1 by 2 plus nc2 into 1 by 3 and so on up to ncn into 1 by n plus 1. Right? What is there in the denominator of right hand side? N plus 1. Obviously, let us multiply n plus 1 out of the both sides. Right? Multiply n plus 1 to both sides. So what do we get? N plus 1 into s is equal to n plus 1 into nc0, n plus 1 into nc1 into, let me write this by 2 here by 1 plus n plus 1 by 3 nc2 and so on plus n plus 1 by n plus 1 into ncn. Right? What is this? We have everything. There is something left. What is that? The first term, that is something is left here. What is that? So there is one more step left. First let me do that. N plus 1 c1, n plus 1 c2, n plus 1 c3 and so on up to n plus 1 cn plus 1. Isn't it? It is simple. So now you can easily add and subtract n plus 1 c0 term. Let us add and subtract n plus 1 c0. Now just see here, n plus 1 c0, n plus 1 c1, c2, c3 and so on up to cn plus 1. That is nothing but, just tell me, we need one more term. What is it? nc0 into 1, nc0 into 1 power 1, 1 power 2, 1 power 3 and so on up to 1 power n. That is nothing but 1 plus 1 whole power n plus 1. 1 plus 1 whole power n plus 1 minus 1. This is n plus 1 s. What was the formula? 1 plus x. What is x? 1. So this is nothing but 2 power n plus 1 minus 1. Therefore, s is 2 power n plus 1 minus 1 by n plus 1. Is it clear? Is it simple? But the prerequisite is our last problem. Both are separate, but the way which we do is simple. Clear? Shall we move on to the next problem? Let's do. Look at the next question here. He gave for r equals 0, 1, 2 and so on up to n. Prove that C0 CR plus C1 CR plus 1, C2 CR plus 2 and so on up to Cn minus 1 Cn is equal to 1 Cn plus R. And reduce these both. First let us prove that. So we have everything C0 CR, that's it. There is no term of x and all those. So what could be the term? Obviously let me write it as 1 plus x whole power n. Okay. So we know that 1 plus x whole power n is nc0, nc1x, nc2x square and so on up to ncr x power r and so on up to ncn x power n. Is it right? That's it. So we want nc0 multiplied with rth term. So what shall we do? Let us let us replace x with 1 plus x. So what happens? nc0 plus nc1 into 1 by x, nc2 into 1 by x square and so on up to ncn 1 by x power n, or else simply ncr 1 by x power r. Is it clear? Now let us multiply both. What do we get? If I multiply these both, what do I get is nc0 nc1x plus nc2x square and so on up to ncr x square, or else simply let us write as ncn x power n into nc0 nc1 1 by x and so on up to ncn 1 by x power n. Is it right? Okay. Or else here you can simply write as plus or minus. There are many things you can do. So if I multiply all those, if I do everything, what could be the coefficient of some term? Here it is 0r, here it is n minus r n. So what could be the term? Let us write coefficient of x power n plus r on RHS is nothing but this term x power n plus r. That will be n plus rth term there, n plus rth term there. If you multiply, you will directly get it as nc0 ncr plus nc1 ncr plus 1 and so on up to ncn minus r into ncn. Right? If you multiply, you will get this terms, no doubt. Right? What about the LHS? If I want to find coefficient of x power r, actually this is x power rth term, sorry, on LHS will be like, what is LHS here? 1 plus x whole power n, here it is 1 plus x whole power n by x power n. This is 1 plus x whole power n into 1 plus x by x whole power n, that is 1 plus x power 2n by x power n. So x power r ka coefficient if we want to find, that is nothing but coefficient of x power n plus r. Why? R into x power n. All the terms will be multiplied. It is in 1 plus x whole power 2n is, what is the formula? General formula. That is nothing but 2n cn n plus r. Yes or no? nc n minus r, obviously 2n c, 2n minus n minus r, if you do that also you will get it as n plus r. Clear? So the coefficient of x power on left side is this and the coefficient of right side is this. So therefore we can write c0 nc0 ncr plus nc1 ncr plus 1 and so on up to ncn minus r into ncn is equal to 2n plus r. Clear? Now since he gave the values of r as 0, 1, 2, 3 and so on up to n, let us substitute r equal to 0. For first thing, put r is equal to 0. What do we get? Here it is nc0. nc0 is nothing but c0 square. Here c1 0 plus 1 again c1 square and so on up to n minus 0, that is n. ncn again this is cn square, that is nothing but 2n cn. What is it? It is nothing but 2n cn. That's what he asked us to prove. Simple. Yes? Next, to find second one, put r is equal to 1. Just check c0 c1 c1 c2 c2 c3. I mean sorry, this is the thing, right? c0 c1 c1 c2 c0 c1 c1 c2. Here sorry, here only it is there, right? c2 c3 and so on up to c 1 minus r into sorry n minus 1 into c1. Yes, n minus 1 into cn. n minus 1 into cn is equal to 2n cn plus 1. 2n cn plus 1. That is what he asked us to prove. Is it simple? But only this kind of theory is important here. Don't get confused. If you clearly observe, you will get these terms. Is it fine? This is actually simple if you get this till here. So you can directly substitute 0 and 1. So nothing to worry. Clear? Fine. What all kinds of problems till now we did? We did expansion problems, that is expanding, finding number of terms, middle term, a particular term, constant term finding, right? Largest binomial coefficient, numerically greatest term. Yes, and after that we also did few problems of this kind of expansions, right? Later we did all the relationship, I mean different varieties of relationship between the coefficients, finding the value of all those, if their coefficients are in terms of AP and all those. Yes, fine. These are all, everything it revolves around a plus x whole power n and 1 plus x whole power n. What if the power is negative, right? What if the coefficient, I mean the sign between 1 and x is negative? There are 4 chances. One is both are positive, simply. One is one positive, one negative, simply like this. One is both are negative. Okay, so how do we solve them? These are 4 varieties. How do we expand them? What is the relationship between them? What are the kind of problems which we are going to deal with them? Right? Just remember, if both the coefficients are positive or negative for this and for this, you will find all the terms as positive terms. For only these two will have alternative negative terms. So you can remember that kind. So based on this, we will do few problems of binomial theorem. And not only that, till now we have seen only integer forms here. Now let us say fractional form, some kind of p by q in the power or here. Okay, we will do all those problems in the next session. Clear? Fine. This is for today. Let us meet in the next session with the more problems of binomial theorem. Thank you.